Hello, Mrs. Houston here again with some Regents review. Number 7, what is the solution to, and then we have our equation there. Okay, the first thing I want to remind you of is that we followed the steps. Don't call me after midnight. Okay, remember we had those steps for solving equations. So that is one strategy that you could use with this. I do want to go through those steps, but then I'm also going to show you a calculator strategy to check after. Okay, so the D stands for distribute, and I'm going to kind of do that up there and then show my work down here. So the 2 plus just has to come down because it's not directly in front of the parentheses like the 3 is. And it's a positive 3, so that's kind of why I didn't circle that plus, but 3 gets distributed to the 2a. 3 times 2a is 6a. And 3 times 1 is 3. All right, so we distributed there. Now we also have to distribute a 3 again. 3 times a is 3a, and 3 times 2 is 6. Okay, so that is our first step, distribute. Step 2 is combine like terms. That's what the C stands for. Okay, when I look on the left side of the equation, do we have any like terms? All right, hopefully you were saying, yes, we do. It's the 2 and the 3, and you would be correct. Okay, so the 6a doesn't change, but 2 plus 3 is 5. So this side can be simplified to 6a plus 5. The other side, we just have a 3a and a 6. They're not like terms, so I'm just going to write them separate. Done with combining like terms. The next step is to move the variable to one side. Okay, so I'm going to move my variables to the left. So this 3 here is positive, so the opposite would be to subtract 3a. So I'm going to subtract 3a from both sides. 6a minus 3a is 3a, plus 5 equals 3a minus 3a is 0. And I just bring down the positive 6. If that was a negative 6 or a minus 6, I would bring down that sign, but it's positive. And then my next step is to add or subtract. I have a plus 5. Remember, my goal is always to isolate the variable. In this case, it's a. So the opposite of plus 5 is minus 5. So I get 3a. 5 minus 5 is 0. That's why I crossed it out. And 6 minus 5 is 1. And then my last step is to multiply or divide. That's what the M stands for. In this case, the 3 and the a are multiplying, so the opposite would be to divide. We end up with a equals 1/3. And I'm going to leave that as a fraction because when I look at my answer choices, I notice that they are in fractions. Okay, now the other strategy that I wanted to go over was using the calculator. Now, I mean, one strategy with the calculator is to just plug in the answers and see which one makes it true. Okay, but I'm actually going to show you, we're going to treat this like a system. If I put one side of the equal sign into y1 and the other side into y2. And remember, when we use our calculator, the variable we're going to want to use is an x. So I'm going to switch those a's out and make them x's. All right, so y1, I'm going to put 2 plus 3, parenthesis, 2x plus 1, close parenthesis. Okay, pause the video now and type this in with me, please. Other side, 3, parenthesis, x plus 2, parenthesis. Again, pause the video if you need to and put that into your calculator with me. All right, so remember, for a system of equations, we're looking, the solution is the point where the two lines intersect. So if we look here, I can see that they're intersecting here, but I can't tell exactly what that is. So I'm going to press second trace, and I'm going to calculate the intersect, which is choice 5. And then remember, once you get back to here, you just press enter 3 times. 1, 2, 3. Okay, notice I get x whoops, equals 0.3333. I'm going to put that repeating bar because it just keeps going on. Okay? Remember, since we had an x in our equation, the x value is our answer, not the y. But luckily, they didn't put 7 as an answer. They do have 1/7, which might trick some people. Okay, but you might also be wondering, well, 0.33333, that's not the same as 1/3. Okay, this is just the decimal form. Remember, a fraction, the bar just means to divide. So if I type in 1 divided by 3, I get 0.33333. So these two are equivalent. You could also, you know, if you put 0.3333333, if you go to the math button and you go to fraction, it will convert that to a fraction for you, if that makes more sense. All right. So sorry, I kind of took a long time on that, but I felt like it was important to go over both strategies. Number 8, one Saturday afternoon, 3 friends decided to keep track of the number of text messages they received each hour from 8 a.m. to noon. The results are shown below. Emily said that the number of messages she received increased by 8 each hour. Underline that. Jessica said that the number of messages she received doubled every hour. Chris said that he received 3 messages in the first hour, 10 the second hour, none the third hour, and 15 the last hour. Which of the friends' responses best classifies the number of messages they received each hour as a linear function? Okay, so I kind of did, because I've read this question before and I have my answer key right here in front of me. I would suggest you read it through it a couple of times. Don't expect to just know the answer instantly because there's a lot going on here. All right, but then when you go back and you really analyze it, Emily said that the number of messages she received increased by 8 each hour. So increasing by 8 each hour is like adding 8 each hour. That's our pattern. Jessica's is doubling every hour. Okay, and remember, doubling means to multiply by 2. Chris didn't give us the pattern, but it says in the first hour, it was 3 messages. The second hour was 10 messages. The third hour was none. And then 15 the last hour. So we're going to say the fourth hour was 15. Okay, and when you look at this, you know, it adds 7, subtracts 10, adds 15. There's no adding pattern. There's no multiplying pattern. This one is more just kind of random. Okay, so when we look at for which one is a linear function, you know, which one do you think it is? We can eliminate the ones with Chris because Chris doesn't really have a pattern. But do you remember what is a linear function? Okay, remember linear is adding or subtracting. Okay, and then exponential is when you multiply or divide. So if this question said, I'm sorry, that would be Emily is the linear, right? But if it said which, you know, was an exponential function, then we would go with Jessica. Okay, so remember that difference. Adding, subtracting for linear, multiplying and dividing is exponential.